So good morning students, once again this is PANCHNATH. As we have started another new chapter, chemical bonding, and I have completed 2 lectures, right? Okay, in the lecture 1 and lecture 2 we have came to know regarding molecules, definition of chemical bond, reason for chemical bonding, right? Then in the previous class yesterday I had covered especially regarding Lewis dot formulae or Lewis symbols or Lewis notations or electron dot structures. Okay, right. See students, Lewis dot formula was given by the famous American chemist D.N. Lewis. Okay, he has given simple notation to indicate or to represent the valence electrons present in an atom or in an element. What are these valence electrons? These are the outermost electrons present in the outermost shell or orbit of an element, which decides actually chemical properties. Okay. Then, what is the significance of this Lewis dot symbols? The significance is, by using this Lewis dot formulae or Lewis symbols, we can know how many valence electrons are there for an element in its valence shell, that is in the outermost orbit. And also I told you second significance, with the help of this electron dot formulae we can predict or we can calculate group valency, not group number, it's group valency. Okay, right. And then for another one, by studying this electron dot structure we can come to know or one can predict how many chemical bonds the element going to form, right? So that's why group valency for especially elements with less than 4 or up to 4 valence electron, whatever you observe in the Lewis dot formula is itself its group number. If it is greater than 4, then you have to use the formula group valency is equal to 8 minus the number of dots in the Lewis dot symbol or Lewis dot structures. Like this yesterday I completed in detail regarding significance of Lewis dot formulae, which is very important. Already I told you. Okay, right. Now in this today's class I will continue with what very important, and also I told you yesterday types of chemical bonds based upon the nature. Based on nature, how the constituent atoms are held together. We are having ionic bond, covalent bond, coordinate bond mainly. Apart from that, hydrogen bonding, okay, then metallic bonding, and if not, van der Waals forces of attraction, right? Okay. Now students, today we will go for especially what is ionic bond, okay, and what is the definition for ionic bond, and what are the characteristics of ionic compounds and the factors favoring ionic bond. That we will try to complete today. Okay, right. Now, what is ionic bond? If you want to define ionic bond, I will explain you with examples. Then you can easily go for the definitions. Okay, right. First, see here. Consider a common example. Consider formation of sodium chloride, NaCl. It's a very common example. It is also called common salt. Okay. Consider formation of sodium chloride. See, when you consider this example, formation of sodium chloride, see students, here you know that sodium is an alkali metal having atomic number 11, 1s2, 2s2, 2p6, 3s1, right? Okay. And chlorine, atomic number 17, having electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. Okay, right. Now observe this. I told you the last class only. The reason for chemical bonding is second reason, to acquire nearest noble gas configuration. So the nearest noble gas which is nearer to the sodium is, just observe here, that is neon. 10, and to this it is argon, that is 18. That means when sodium loses one electron, so it will acquire nearest noble gas configuration of neon. Okay, and chlorine, when it gains that electron, it will acquire the nearest noble gas configuration of argon, completing both what octane. S2P6, S2P6. Right? So see here, after losing sodium, you get positive charge, 10 electrons, 1s2, 2s2, 2p6. Okay, this one. And that electron is gained by this chloride, Cl minus, that is 18. 1s2, 2s2, 2p6, 3s2, 3p6. See, this electron has transferred. Right? So, please remember what you observed here. Sodium, after losing one electron, acquires S2P6. Chlorine gained the electron, acquires S2P6. And both they acquire nearest noble gas configuration of neon and nearest noble gas configuration of argon. Right? That means the element which loses electron acquires positive charge. Okay, and element which gains electron, it acquires negative charge. That's why Na plus sodium cation, chloride anion, Cl minus, which I already told you in the previous. That is what in the introductory class in the bridge course. Okay, students. That means now how? Now the force of attraction between oppositely charged ions. Force of attraction between the oppositely charged ions. That means Na plus and Cl minus. Force of attraction between oppositely charged ions leads to what? Ionic bond. That is called an ionic bond. Okay? Right. This is one example. That means this ionic bond is represented as one strong line, NaCl. Right? Okay. Sodium chloride. Right. Next, another example. Not only is this sodium chloride, I will tell you another more examples. Second example, if you consider second one. Second example, if you consider is formation of calcium chloride, CaF2. Just observe here. Formation of calcium chloride solids. Calcium chloride, you know that calcium is having atomic number 20, right? 1s2, 2s2, 2p6, right? 3s2, 3p6, 4s2, right? Okay, then chlorine, one chlorine atom atomic number 9, 1s2, 2s2, 2p5, right? Like this, how many chlorine atoms are there? 2. So 1s2, 2s2, 2p5. Okay? Right. Now see here. If it loses 2 electrons, it will acquire nearest noble gas configuration of what? Argon. And if it gains 1 electron, it will acquire nearest noble gas configuration of neon. Okay? So, see here. These 4 s2 electron valence cell only will transfer to this, right? Yes. And thereby, these after gaining, what will this? 1s2, 2s2, 2p6. This also 1s2, 2s2, 2p6. That means I want to tell you that this is F minus, F minus. And this will, see, it has lost 2 electrons. Therefore, it will acquire Ca2 plus. If it loses 1 electron, plus 1. 2 electron plus 2 or 2 plus, right? So Ca2 plus. Now see here, total number of positive charges is equal to total number of negative charges. But I told you while writing formula, calcium when it's involved, Ca2 plus. Chloride is F minus. Okay? So on cross multiplying, what will write? CaF2, calcium chloride. That's why it was ionic in the nature. That's why I tell you 2F minus. That means you write in the terms of electron dot formula calcium 2, right? Chlorine 7. Okay, this also fluorine 7, right? Now these electrons, see, here and here, thereby giving what they will complete? They will complete F minus, and this is the 2 plus after losing. Therefore, it is CAF. Like this. So here also see, after calcium losing 2 electron, acquire nearest global gas configuration of argon 18, and fluorine by gaining 1 electron, acquire nearest global gas configuration neon. Because since there are 2 fluorine atoms, that means calcium will give 1 electron, donate 1 electron to each fluorine atom. Thereby forms calcium fluoride, CaF2. Therefore, CaF2 is also what? Not a covalent, it is ionic in nature. Like this can decide nature of the compound. These are the very best example. Not only this, because you can take for example, magnesium sulfide, MgS. Another third example, magnesium sulfide, MgS. See, magnesium atomic number 12, 1s2, 2s2, 2p6, right? 3s2. Whereas sulfur atomic number 16, 1s2, 2s2, 2p6, 3s2, 3p4. Okay? See, after losing, this will acquire Mg2 plus. That means 1s2, 2s2, 2p6, right? That's gone. When these are gone, these are donated to this. So sulfur, after giving 2 minus, okay, this is 10, and this will be 80. 1s2, 2s2, 2p6, 3s2, so it can become 3p6, right? See, S2p6, S2p6. It acquire various global gas configuration of once again what? Neon, and it acquire various configuration of argon. That's why, students, I told you very clearly that the main important reason for chemical bonding is what? Acquiring nearest to noble gas configuration, right? Okay, that means by these 3 examples, what you come to know, students, how to define now ionic bond. So what is ionic bond? See, ionic bond is a type of bond which is formed by with this example. What you see here, in sodium also you see it has transferred 1 electron. And second example, calcium has transferred 2 electrons. Okay? And in third example, magnesium sulfide Mg2 plus S2 minus C. That cancels Mg, yes. That's why I just observed here. Magnesium sulfide Mg and sulfur, same electronic configuration. It donates 2 minus and 2 plus gets cancelled, and it is going to form what? MgS. Right? So students, that means the bond which is formed by complete transfer. The bond which is formed by what? Complete transfer of an electron, a single electron, example sodium, pair of electron, example calcium, or more than a pair of electron. Okay? Sometimes more than pair of electron also. That type of bond which is formed by complete transfer of electrons or pair of electrons from one shell of atom to another shell of atom is called ionic bond, which is a very simple definition. Or the force of attraction between electropositive element and electronegative element is called ionic bond. Or the bond which is formed by attractive force between oppositely charged ions is called ionic bond. Okay? And you have seen these examples. What are the examples? Sodium chloride, NaCl, okay? Then calcium chloride, CaF2, magnesium sulfide, MgS, right? These are all ionic in the nature. That means the bond which is formed by complete transfer of an electron or a pair of electron from one shell of atom to another shell of atom is called ionic ionic bond students. क्या बच्चे? देखो what is ionic bond क्या है? Ionic bond बोले तो bond which is formed by transfer. कितना? एक इलेक्ट्रॉन, नहीं तो दो, नहीं तो तीन इलेक्ट्रॉन. कहाँ से कहाँ? One shell to another shell. But by transfer word is important. Donor. Okay, that is called ionic bond. Right, students? Okay. Now, after understanding definition, if they ask you, which will be asked for theory purpose for 2 marks. Explain formation of ionic bond with an example. With an example, if they ask for 2 marks. Then you should be able to take one classical example, especially from your NCERT textbook, that is sodium chloride. See, I have given you here 3 examples to understand the definition. Don't get confused. You can write only one example. Okay? So we will run this second example and third example. If they ask you, then you should be able to represent very easily. Just observe here. Ionic bond with an example. Consider formation of sodium chloride. Write the electronic configuration. First sodium 1s2, 2s2, 2p6, 3s1. Right? Then after losing one electron, we will acquire nearest local gas configuration of D. Okay? Then chlorine you write ground state 1s2, 2s2, 2p6, 3s2, 3p5 because atomic number 70. Right? And when it donates and it excels. Why? Because sodium is electropositive and chlorine is electronegative. Next, the bond which is formed by transfer of electron from electropositive element to electronegative element is also called ionic bond in a very simple way. Okay? Right. So like this you can represent them, and the bond which is formed by force of attraction between oppositely charged ions is called ionic bond. That's why ionic bond is also called by another name electrovalent bond. Okay? It is also called electrovalent bond. Why? Because it is formed by complete transfer of electron from one cell of atom to another cell of atom, or the bond which is formed by force of attraction between oppositely charged ions. That is called ionic bond. That's why it is also called electrovalent bond between the ions. Okay? Right. Okay, that means from the 3 examples, students, what you come to know the common factor? क्या common factor आपको दिख रहा है एग्जाम्पल से? देखो फिर से मैं एग्जाम्पल्स दोहराऊंगा. क्या is the example? Sodium chloride. Okay. Then second example was calcium chloride. Okay. Then third example magnesium sulfide दिया था. Okay. थोड़ी मूल एग्जाम्पल को दे. Sodium chloride मतलब calcium chloride मतलब magnesium sulfide. तो मूलದಲ್ಲಿ ಏನು ಕಾಮನ್ ಒಂದು ಕ್ಯಾರೆಕ್ಟರ್ ಕಾಣುತ್ತೆ. ಏನಪ್ಪ ಅದು? ಫಸ್ಟ್ ಒನ್ very simple. Sodium is metal, chlorine is non-metal. Calcium is metal, chlorine is non-metal. Magnesium is metal, sulfur is non-metal. Not very simple. That's why ionic bond is always formed between a metal and a non-metal. And you know that metals are electropositive and non-metals are electronegative. Not electropositive means it is a tendency of an element to donate the electron. Okay, one is donates, acquires positive charge. And what is electronegative? Electronegative element or electronegativity is the capacity of an atom to attract the bonded pair of electron towards itself. That means electronegative element gains electron, electropositive element donates electrons. By donating it acquires positive charge, by gaining it acquires negative charge. That force of attraction between oppositely charged ions, that attractive force which binds these constituents is called ionic bond, and that's why it is also called electrovalent bond. Okay? So, in these 3 examples, now I will try to write a definition. What is the definition? Simple definition, students. The force of attraction between the oppositely charged ions. Oppositely charged bond which is formed by transfer of an electron from electropositive element to electronegative element. Okay, it's called ionic bond. Okay, right. Next, you can also give this definition as the bond which is formed by complete transfer of an electron or pair of electrons from one shell of an atom to another shell of an atom. Another shell of an atom is called ionic bond. Okay, so these are the three ways of defining ionic bond. So don't get confused, students. You can write any one definition out of here. Especially the force of attraction between oppositely charged ions or bond which is formed by force of attraction between oppositely charged ions is called ionic bond. That's why I told you ionic bond is also called electrovalent bond. If they ask you definition, this second one. The bond which is formed by transfer of an electron from electropositive element to electronegative element is called ionic bond. And ionic bond is also called electrovalent bond by Q reason. If they ask you, then you can write. See, it is also called electrovalent bond. Why? Because it is a force of attraction. It is a bond which is formed by force of attraction between oppositely charged ions. That's why it is also called electrovalent bond. Okay. General point and what I told you, always this ionic bond is formed between a metal and non-metal. Metals are electropositive, non-metals are electronegative. Okay. So with these three examples and definition, now let us take you to next part. What is that? What are the characteristics of this ionic compound? I'll repeat once again. If they ask you for 2 marks in theory, take example of sodium chloride. Consider sodium chloride, write electronic configuration, ground state, then losing Na plus and gaining Cl minus. Okay, that carries 1 marks. Then definition: the bond which is formed by transfer of an electron from electropositive element to electronegative element is called ionic bond. Oh, just will get 2 marks, right? Okay, why it is also called electrovalent bond? Because it is formed by the force of attraction between oppositely charged ions or electrostatic force of attraction between oppositely charged ions. That's why it is called electrovalent bond. Okay. Now with this background, I will take you to the next part, that is what are the characteristics of ionic compounds. Right? Okay. Now with this definition, we will go for what are the characteristics of ionic compound. So it is ionic compounds, not ionic bonds. Okay. What are the common characteristics of ionic compounds? Okay, what are the characteristics of ionic compounds? See, very simple. With the part 2 marks generally, and this part is purely for CET and NET purpose. Okay? Sometimes for 1 mark in theory also they will ask you. Let us see. First one. What is the physical state? What is the physical state of these ionic compounds generally? How they exist? See, all ionic compounds, right? All ionic compounds exist in solid state. They are all crystalline solids. Okay, they are all crystalline solids. Sorry. They exist as crystalline solids. Crystalline solids no doubt, but that means all ionic compounds exist in solid state, especially they exist as crystalline solids. See, solids once again there are two types, crystalline solids and amorphous solids. Okay, in crystalline solids the particles are very tightly packed without any interspace or any space, without any space. Okay, and they are held in where? In one of the important part is called as crystal lattice. Crystal lattice, right? To break it we need more energy. That will come down in solid state chemistry next year. Okay, but just observe, just remember. They exist mainly as crystalline solids. Then, after physical state, next one is about regarding solubility. Solubility. What is their solubility? Ionic compounds are soluble. Okay, they are soluble in polar solvents. Polar solvents like water. Polar solvents like water, but insoluble in non-polar solvents. Okay, that is in the organic compounds like acetone, benzene, toluene, xylene, methyl alcohol, okay, and ether. So many examples. That means ionic compounds are generally soluble only in what? There in the polar solvents. Because here, according to the principle of solution chemistry, like dissolves like. What is the principle? Like dissolves like. Means polar compounds are soluble in polar solvents. Unlike dissolves unlike. Unlike dissolves unlike means non-polar compounds are unlike dissolves unlike. Non-polar compounds are soluble in non-polar solvents. Repeat, polar compounds are soluble in polar solvents, whereas non-polar compounds are soluble in non-polar solvents. That's why like dissolves like, unlike dissolves unlike. This is a very basic principle behind the solution chemistry. See, one example I will give. Generally, see, in day-to-day examples, if you are making your friends, you will make one very close friend, right? Another one just hi-bye friend, right? Like that. See, if your characters match each other, that friend will become close to you, like that. Like dissolves like. Another one, you don't. What means like you don't like him. That's why if they don't like, then they dissolve. Like this here is applicable. Okay, so that means ionic compounds are soluble in only polar solvent like water, but insoluble in non-polar solvent. Non-polar means which do not carry charges. Polar means which carry both positive and negative poles, that is charges. Remember. Okay, right. Definitely see all crystalline solids, they are soluble in the water. And third one regarding MP and BP, melting point and boiling point. See, ionic compounds have melting point and boiling points. Okay. High melting point and boiling points. Why? Because they are held in the crystal lattice. What is the word? Crystal lattice. What is this crystal lattice? This crystal lattice is the basic unit of all crystalline compounds in which cations and anions are held very tightly through ionic force. If we want to break that, we need more energy. That's why ionic compounds are having high melting point and boiling point due to they are tightly packed in the crystal lattice, which is the basic unit of all crystalline compounds. Okay? Right. That will come to where in the next year in solid state chemistry, in solid states. Okay. Now coming to after melting point and boiling point, now regarding conductivity. Regarding conductivity, see here, students, ionic compounds are good conductors of heat and electricity. Good conductors of heat and electricity. Right? So these are the four common general characteristics of ionic compounds. What are those? All ionic compounds, what? They are in solid state, especially they exist as crystalline solids. Okay? Then ionic compounds, all ionic compounds are soluble in polar solvents like water. But insoluble in non-polar solvents like acetone, okay, ether, benzene, toluene, xylene, so many examples. That means all organic compounds are non-polar solvent. Why? Because they do not carry charges. Some examples are exception. Those exception examples are what? When which form hydrogen bonding with water, they are soluble. Otherwise, all are insoluble in water. So remember, all organic compounds except forming hydrogen bonding with water, they are non-polar solvents. Very easy to remember, right? Then NP and BP, they are having high melting point and boiling point. Why? Because they are tightly packed in the crystal lattice. First, if you want to break them, you have to break that crystal lattice. That's why they are having high melting point and boiling point. And since they are ionic in nature, they exist in ions, even in the crystalline solids. But generally, ions are found in their aqueous solution. One exceptional example, the X-ray diffraction method. This is the method by powdered X-ray diffraction method. We can study the characteristics of ionic compounds. Even the X-ray diffraction reveals that ions are formed in the solid state. Only one example, that's existed example is sodium chloride. Remember that this is the exceptional case. Generally, ions are not formed in solid state. Ions are formed only in the aqueous solution. That means in fused state they are bad conductors, but in aqueous solution they are very good conductors of heat and electricity. Right? Okay. Now what about directionality? Whether it is a directional or non-directional bomb. See. Lastly, fifth one. This is first, second, third, fourth, and fifth one right here because space is not there. Fifth one, ionic bond. Ionic bond is non-directional bond. Okay? Non-directional. It is non-directional bond. There is no any fixed. No doubt they are having positive and negative charges, but it is a non-directional bond. Okay? That means ionic compounds are non-directional in nature. Non-directional, that means the pair of positive and negative charges, they will not what we call it as overlap each other. That's why it is called non-directional. That means one element should be electropositive, other element should be electronegative. Then only it is possible, otherwise not possible. Right? These are the characteristics of ionic compound. If they ask for 2 marks, you can write any 4. Right? Okay, very easy to remember. Physical state, solubility, melting point and boiling point, conductivity, and directionality of the bond. Like this, you can remember characteristics. Then you can easily write it. Okay? Right. This is about characteristics of ionic compounds. Right. Now let us go for next one. Factors favoring ionic bond. Factors favoring ionic bond. Okay, after understanding definition, various examples, characteristics of ionic compounds. Okay, then now it's a turn now. Factors favoring. Factors favoring. Factors favoring. Okay, ionic bond. Factors favoring ionic bond. What are the factors responsible for or which will help to form ionic bond, which favors ionic bond? Right. First one, tell you, low ionization energy. Low ionization energy of metal. Okay, metal. Then second, high electron gain enthalpy. High electron gain enthalpy, or it's also called electron affinity. Electron gain enthalpy or electron affinity. High electron enthalpy of non-metal. Okay, and third one, high difference. High difference in what? High difference in electronegativity. High difference in electronegativity of combining atoms. And also fourth one, high lattice energy. High lattice energy. High lattice energy of the combining atoms also favors, okay, ionic bond. And this is important for theory, especially for mention the factors favoring ionic bond. Then we should be able to tell these four: low ionization energy of metal, high electron gain enthalpy of non-metal, and high difference in electronegativity of combining atoms, which is very, very important. Okay, will favors. At last one, even high lattice energy. I am telling in detail what is this lattice energy and how it contributes for the formation of ionic bond. Okay, right. I will now tell you one by one these factors. How these are responsible for formation of ionic bond. Okay. First point I want to clear: low ionization energy of metal. Okay. Low ionization energy of metal. How it favors formation of ionic bond? Very simple. See here, students. Low ionization energy of metal. I told you already. First point: this ionic bond is formed between a metal and non-metal. Compulsory. Metal electropositive, non-metal electronegative. Metal देता है, non-metal लेता है. Right? Okay. So this exchanging will take place here. That will transfer. That bond is ionic bond. Okay. Now, first of all, in the periodicity of elements, now you already studied ionization energy. What is ionization energy? Ionization energy is the energy required to remove an electron from isolated gaseous atom. Remember, isolated gaseous atom. I am telling you the word isolated gaseous atom because you cannot remove electron directly from solid atom. First, you should convert solid atom into gaseous atom. Then only you can remove the electron from isolated gaseous atom. So, the energy which is required to remove the electron from isolated gaseous atom so as to convert it into cation is called ionization energy. What it is called? Ionization energy. I will repeat. The energy required to remove an electron from isolated gaseous atom so as to convert it into cation is called ionization energy. See, I am stressing on the word cation. Whenever any element loses, it will form positively charged ion is called cation. Cation. Remember. So, in alkali metals, if you take for example alkali metals like lithium, sodium, potassium, rubidium, and cesium, and francium. Okay? And I told you, these are called alkali metals. So, if you go down 3, 11, 19, okay, 37, 55, and this is 32. 32 means it will be 87. Right? Okay, that means lithium, sodium, potassium, rubidium, cesium, francium. Francium is a radioactive element. Leave this. You go down the group, see size, atomic size increases. Atomic radius increases. Distance between the nucleus and outermost orbit increases. Then you can easily remove the electron. See, radiation energy is very much high for lithium. Go down, new substances are going to be added. Distance between the nucleus and outermost orbit. This will goes on increase. The nuclear force of attraction increases, then you can easily remove the electron. Then ionization energy will definitely decrease. So, ionization energy and atomic size, they are inversely proportional. Smaller the size, higher the ionization energy. Larger the size, lower the ionization energy. Therefore, low ionization energy leads to formation of what? Cation. Cation favors formation of cation. So here, if you just see cesium, just light falls on the cesium, electrons are ejected out. As I have told you in the atomic structure, they will what? Rubidium and cesium. They show what? Photoelectric effect by forming Rb plus Cs plus. Because general electronic configuration of alkali metals is also NS1. They can lose only one electron easily. Not lithium, but it's a cesium. That's why low ionization energy favors what? Formation of cation. That's why if you take sodium, the best example, that is 11, 1s2, 2s2, 2p6, 3s1. Okay? It can easily lose by forming Na plus 1s2, 2s2, 2p6. Okay, right. Now next, high electron gain enthalpy. High electron gain enthalpy. High electron gain enthalpy of what? Non-metal. See, non-metal generally they are most electronegative. What is electronegative? Negativity, it is the capacity of an element to attract the bonded pair of electron towards itself. Bonded pair of electron towards itself. Means electrons को अपनी तरफ खींचना. That is called खींचिंग effect. Okay, just I am telling you, just making you the joke, right? Don't confuse. It is the capacity of an element to attract the bonded pair of electron towards itself. That is called electronegativity. But what is electron gain enthalpy? It is energy liberated. When an electron is added to isolated gaseous atom, so as to convert it into an ion. Therefore, electron gain enthalpy is always exothermic. Heat is liberated, energy is liberated. But electronegativity is also electron accepting tendency. Electron gain enthalpy is also electron accepting tendency. But which is most correct one? The most absolute one is electron gain enthalpy. That's why very important. So higher electron gain enthalpy of non-metal, more the tendency to attract the bonded pair of electron towards itself. When it gains, definitely it favors for formation of anion. देखो इलेक्ट्रॉन गेन एंथैल्पी अगर ज़्यादा रहा तो एलिमेंट इजीली क्या करता है? इलेक्ट्रॉन को एक्सेप्ट करता है. अगर इलेक्ट्रॉन को एक्सेप्ट करे तो क्या हो गया? उसको नेगेटिव चार्ज आ गया. नेगेटिव चार्ज आया तो इसको क्या बोलते हैं हम? एनायन. राइट. ऊपर क्या बोलते हैं आपको? लो आयोनाइजेशन एनर्जी फेवर फॉर्मेशन ऑफ कैटायन. कैटायन रेडी हो गया, आयन भी रेडी हो गया, दोनों क्या हो गया? दोनों की तरफ राजी हो गया तो आयनिक बॉन्ड फॉर्मेशन हो गया इजीली. राइट. ओके. नहीं अभी भी राजी तो खाजी क्या करेगा बोले तो ऐसा है. राइट. सो हियर हाई इलेक्ट्रॉन gain enthalpy favors anion. This is cation and this is anion. So taking the same example, chlorine 17, 1s2, 2s2, 2p6, 3s2, 3p5. It gains electron which is given by that is sodium. Then it will acquire 1s2, 2s2, 2p6, 3s2, 3 enthalpy favors what? Anion. Now both cation and anion are ready. And what? The force of attraction between oppositely charged ions leads to formation of bond called as ionic bond. Simple. That's why third factor favoring is what? High electronegativity. High electronegativity between the combining atom. Compulsory there are two atoms. One is metal, another is non-metal, which is less electronegative, that is electropositive. Metal is electropositive and non-metal is electronegative. Right? That's why high electronegativity difference between the combining atoms leads to formation of ionic bond. And lastly, lattice energy. Even high lattice energy is also responsible for favors formation of ionic bond. And remember, I told you students, these ionic compounds exist in normally crystalline solids. That's why they have what? Crystal lattice energy. What is this lattice energy? It is the energy liberated when 1 mole of ionic compound is formed by close packing of gaseous cations and gaseous anion. That is called lattice energy. Right. So that also I will tell you tomorrow in detail how lattice energy favors for the formation of ionic bond, because this is very important for CET and NEET purpose. I will discuss some questions here so that it will be very clear for you for further concepts. Okay, that means we will stop here. What I covered today, definition of ionic bond. What is ionic bond, students? The force of, see, it is a type of bond which is formed by complete transfer of an electron from most electropositive element to most electronegative element. Or else the bond which is formed by complete transfer of an electron or a pair of electron from one cell of atom to another cell of atom. Right? Or the bond which is formed by complete transfer of electron. The bond which is formed by force of attraction between oppositely charged ions is called ionic bond. What are the characteristics of ionic compounds? Mainly they exist as crystalline solids. They are soluble in polar solvent like water, insoluble in non-polar solvent like organic solvents. Okay, they are having high melting point and boiling point. They are good conductors of heat and electricity in aqueous solution. Okay, except sodium chloride, which is depicted by X-ray diffraction method. Even in a solid state also it exists in the ions. Please remember, point to be noted. Then ionic bond is a not a directional bond. It's a non-directional bond because the electrons will not pull over another atom. That's why it is called non-directional. They are not fixed. Okay, right. Now lastly, factors favoring ionic bond. The factors which favors formation of ionic bond are low ionization energy of metal and high electron gain enthalpy of non-metal, and what? The high difference in electronegativity between the combining atom favors ionic bond, and high lattice energy also very equally important for formation of ionic bond. Right. So these are the 4 factors. Out of this you can write any 2 or 3. You will get 2 marks for thing. No need to explain. Just mention the concepts. Okay. Right. Now tomorrow I will tell you very importantly some points regarding CET and NEET with respect to this ionic bond. That will be the completion of ionic bond. Right, students? Have a good day, and once again bye from PANCHNATH.